something to look at. Green, that's fine. Properties of real numbers. Now that first class, did I talk about the real numbers? I can't remember. Small numbers, counting numbers, integers, all that fun stuff. So to start off the property of real numbers, one thing that they have to agree on is the identity property. And the identity property is pretty simple. It only has two operations, addition and multiplication. It does not exist for subtraction. Well, there's no such thing, let's say, as subtraction and or division. Subtraction definitely is a sub-operation of addition, and division is a sub-operation of multiplication. They're basically the same thing, it's just how they're written. So when we talk about the additive identity, it's what number do you add to some number A to come back to the original number A? That should be easy. 0. So 0 is considered the additive identity. It's one of the properties of 0 that's kind of neat. The multiplicative identity then becomes, what do you multiply A by to get back to the original A? 1. Now, this property here is probably really important for most of algebra, because a lot of people lose fact of this one thing. It's usually written this way, though. If you have x, you can also write it as 1 times x. That's what allows you to write that 1 in front of any variable that you see that does not have a coefficient. It has an understood coefficient of 1, and that's just the identity property. So that comes in very, very handy for a lot of different parts of algebra. And it gets rid of silly mistakes, like when people go x plus x and they say x squared. I had someone do that to me the other day in college algebra. I was just like, but it happens because your brain's not thinking through things. All right, according to the identity, there's another property, and you have to have the identity first for this next property work, and it's called inverse. Inverses are what you use to solve equations, linear equations specifically. So an inverse works this way. If you have A, and you add some number to it, and you want it to equal the additive identity, which is 0. So on this side now we have 0. So what do you add to A to make it equal to 0? Negative A. These are considered additive inverses. Think about when you're solving an equation. If you have x plus 5 is equal to 7, what do you do to both sides? Subtract 5. It's its additive inverse. So that's where these inverses come in. Especially this one that usually messes up people. Multiplicative inverse. You want it equal to the multiplicative identity, which is 1. What number has to go here to go A times something is equal to 1? A times 1 is equal to A from up here. A times negative A is negative A squared. Any other guesses? You did it yesterday. All you did.
44.
No. 5 times, what is it? No, because A times negative 1 would be negative A. What times A is equal to 1?
0.
A times 0 is the 0 multiplication property that equals 0. Say it again? 1 over A.
Oh, yeah, that's right.
It's reciprocal.
That's right.
It's reciprocal. So when you do A times 1 over A, I mean, if you go off to the side and you go A times 1 over A, what can you put underneath the A?
1.
What property allows you to do that? Nope. The identity. Dividing by 1 is the same thing as multiplying by 1.
That's right, that's right.
So I can put a 1 under here. How do you multiply fractions? Straight across. A times 1, A. 1 times A, A. A divided by A, 1. So it's a multiplicative inverse. That also comes in handy for solving equations. You have 2x is equal to 5. How do you solve for x? You have 2x is equal to 5. How do you solve for x?
Divide by 2.
Get rid of the word divide. How do you solve for x? Multiply by
2.
1/2. You multiply both sides by 1/2. Dividing by 2 is the exact same thing as multiplying by 1/2. Dividing by 5 is the same thing as multiplying by 1/5. So you have to get the language right, because sometimes you want to say divide and sometimes you want to say multiply. For instance, if you have 2/3 x is equal to 8. Now, I've done this two different ways. When I was in 8th grade, I was taking algebra in 8th grade. I would multiply both sides by 3 and then divide by 2, but you could do it in one step. What can you multiply both sides by? 3/2. You just do the multiplicative inverse. And it does it in one step rather than two. So some of these things are, little tricks that you can pull and use all the way through math. All right, so this is additive identity, additive multiplicative identity, additive inverse, multiplicative inverse. I love that word, multiplicative. Multiplicative. All right, the other identities, 3. Commutative. And the only way I keep this straight in my head is I think about commuting to work. I come to work, and then I go back home. So I go from home to work and work to home. And all that's happening is the order is changing. So all commutative does is change order. So if you find that things are out of order, more than likely you use the commutative property. The additive version, of course, is a plus b is equal to b plus a. The multiplicative version is a times b is equal to b times a. Can subtraction be commutative? Is 5 minus 2 the same thing as 2 minus 5? No. One is positive and the other one is negative. Totally different values. Even though the number is still 3, one's a positive 3 and the other one's a negative 3. Can division be commutative? Is 5 divided by 2 the same as 2 divided by 5? Some people think so. You'll find when you're solving equations that sometimes you do the operation backwards because you're used to moving things left to right, and the question it really wants you to move right to left, but your brain still goes the other direction. So you'll do that every once in a while. 4, probably the hardest one for people to see. The associative property of real numbers. Now, associative is how do you work with 3 numbers rather than just 2? All these operations, addition, subtraction, multiplication, division, are called binomial operators. What's bi mean? 2, like a bicycle. So it only works on 2 numbers. So if you throw 3 numbers at it, it gets very, very confused. And you get very, very confused. So if you have 3 numbers, a plus b plus c, you have to pair them up. You can't just do it all at once. Nobody in the world can go 2 plus 3 plus 4 and come up with an answer with one calculation. They have to do 2 separate ones. So you have a choice. You either add the first 2 together. When you put parentheses around it, remember that happens first. Please excuse my dear Aunt Sally. So this forces the operation to work on a plus b first. You get an answer for it. Then you take that answer and add it to c. But that's the same thing as if you have a plus b plus c, as taking the last 2, adding them together, and then taking that result and adding it back to a. So it's just saying you can either add the first 2 or you can add the last 2. It really doesn't matter. Where commutative, this is where people get confused though. You have to be really careful. Commutative changes the order of the numbers themselves. So if you see ABC and BCA, it is not the associative property because the order of the numbers have changed. That's commutative property. Associative, the only thing that's moving are the parentheses. Did I spell that right? And they have to move over different numbers. See, it's the commutative property if I write a plus b plus c is equal to c plus a plus b. Because then I'm taking the a plus b and I'm moving it physically, so that becomes a commutative property. The parentheses are still around a plus b then. So you have to be a little cautious between these two, especially when you're working with 3 numbers. Just because you're working with 3 numbers does not guarantee you're working with the associative property. All right, multiplication is the same thing. You either have the choice of multiplying AB first, getting an answer for that, and multiplying it by C, or you can multiply BC first and take an answer of that and multiply it back to A. No, this does not work with subtraction. You can't have a minus sign anywhere here and move the parentheses over any two numbers that you wish, which gets really weird if you have something like 4 minus 3 plus 2. The parentheses are guaranteed only in one place in this problem. Where are the parentheses guaranteed?
3 plus 2.
No.
4 minus 3.
4 minus 3.
Yeah,
You have to do it left to right, so you're forced to do 4 minus 3 first and then add the answer to 2. If you did this,
makes that -3.
what property comes into play?
Multiplication.
The next one I want to talk about,
Distributive.
distributive. And then it makes it a -3 and also a -2.
2.
But that's not a -2, that's a +2. So you have to be really careful. If there's subtraction involved, don't be moving parentheses. It has to go left to right. The same thing with division. You can't just put parentheses where you want them. They have to go left to right. So associative property only works with pure addition and pure multiplication. All right, the most powerful one that we're going to be using is this last one. There are others, and I'll talk about them as we go through the class, like the multiplicative property of equality, the additive property of equality, but most people usually understand those. Distributive. Distributive property. The distributive property is a combination of addition and multiplication, or subtraction and multiplication. It actually works with addition and or subtraction. This is equal to, y'all know this one, right?
AB plus AC.
AB plus AC. Distributive means it's kind of like handing out papers. Everybody's going to get an A. So A is going to go to B, and A is also going to go to C. Most people are used to seeing it in this order. A lot of people forget a simple property of math. If I write A is equal to B, is not B also equal to A? Yeah, it's actually called the reflexive property of equality, but I don't want to get into a bunch of those yet. So the reflexive property of equality says I can take this whole equation and flip it around. So I can write it as AB plus AC is also equal to A on the outside and B plus C on the inside. And I can mess it around just a little bit more. This is also equal to, this is a product of two numbers, right? It's A times the other number, which is B plus C. What can I do with the product of two numbers? Well, I can take their order and also switch them. What property is that? Commutative. When you're changing orders, it's commutative. So I can also write this as B plus C, push the A off to the right. Most people call the blue part there factoring. They call it factoring. You're either pulling A out to the left side or you can pull A out to the right side. And technically, if there was another letter in common, you could pull one to the left and one to the right, which is kind of cool if you think about it. But it's all these properties coming together to start building some more cool things. All right, why is the distributive property the most important so far? The other ones you do kind of in your head, and sometimes that'll make mistakes, especially when you do things like this, put parentheses around the wrong thing, or assume an operation is distributing over chunks, or worse yet, not distributing what really should be distributed. And I'll show you some examples of those. Distributive property, ready? You're all looking at me like, that's not the distributive property. What do you call that? What do most math teachers call this piece?
An equation.
You're going to add them together because they have like terms. But if you look on this entire board, there is no property of like terms. So there is really no such thing as like terms. It's just a shortcut language that math teachers like. And eventually we'll get back to it, but I need you to see this as a distributive property. The distributive property says if they have something in common, I can either kick it out to the left or I can kick it out to the right. What do they have in common? X. So when you kick it out, I'm going to kick it out to the right because it's a variable. I like kicking numbers to the left and variables to the right. After I kick it out, what's left inside? 4 plus 7, which is the same thing as 11x. This is why when you add x plus x that you don't get x squared. I had people, when I taught 80 a long time ago, they would do 4x plus 7x is 11x squared, because they were trying to deal with that having 2 x's, and they wanted to represent 2 x's. But that's not what's going on. The x gets ignored. You add the numbers, and that's pretty much what you do in your head, right? You see that they have like terms. You ignore the like terms. You look at their coefficients. You add them together. This is what you do in your head. So whenever you're doing like terms, it's the distributive property in disguise. Why do I need you to do this? Well, what if you have something like this? Are they like terms? Yeah, they both have an x. Can you add them together? Yes. How?
Calculator.
No, that's an approximation. Yeah, kick the x out. You kick the x out, what's left behind? I plus 3. Perfectly fine answer. It's just that you can't take the pi and the 3 and bring them together because one's irrational and the other one is rational. Now you can type them in a calculator. You can approximate pi with 3.14, which is a horrible approximation. But you can add them together in your calculator and get a decimal answer, but that's an approximation. This answer is exact. It's perfect. It's no rounding, nothing going on with it funny. So that's what's important about like terms in my way. Later in the course, we're going to do something like this. And I'll say, can you add these together? And your answer better be yes. What do? Kick the x to the side. You're going to get a plus b and an x on the side. They're equal to each other. And therefore, you're taking 2 terms and you reduce it down to 1. That's what combining like terms is all about. Taking more than what you have and shrinking it down to less. All right, so these are the properties. We'll be using them all throughout the semester. When we start solving linear equations, I'm going to come back to them, and everything we do, I'm going to have you come back to these properties. For the beginning part of the class, I do that. Later on, I'll just let you solve it any which way. But in the beginning, I do want you to know what these nice little properties are. And I don't want you to memorize them. I'd really rather you understand why you're doing things the way you're doing them. And that way you don't come up with ambiguous answers, ones that you're not sure of. With the properties, you should be sure of everything you do, because everything has to come back to inverses, identities, associative, distributive, and commutative properties. They have to, in some way or form. All right. No. This one. Let's start with the book now. We'll start kind of in the middle of the chapter, 1-4. I don't do a lot of teaching out of the book, but I'll probably steal some examples so you can see what kind of problems you'll be asked to do. So 1-4 is, what do they call it? Integer exponents?
Yeah, scientific notation.
Yeah, integer exponents. I guess I could teach you something now on the fly. What's an integer? What's an integer? Well, it's a kind of number. Specifically, what kind of number is it?
Top number of fraction.
Top number of a fraction. I guess you could go with that kind of definition. What kind of numbers? Give me an example of integer. Integer. Just any number you can think of off the top of your head, and I'll tell you if you're right or wrong. Okay. Give me a number. 2? No variables. Just plain old numbers. 2, 1. That's an integer. 6 is an integer. -2 is an integer. 5 is an integer. 8. 9. 20 is an integer. So what makes an integer an integer? think of the answers. They were counting numbers, 1, 2, 3, 4, 5, 6, 7. And they are also,
Real number?
there was one other answer in here.
Negative.
Not natural. It's part of the natural numbers, but one other answer was different than the natural numbers.
Negative.
Negative. They are negative and positive whole numbers. Now, whole numbers have one special little symbol. And that symbol is 0. So when you're talking about integers, you're talking about the set of numbers that are negative, 0, and positive whole numbers. And there's an infinite number of these things. But they are not fractions, they are not decimals, and they are not irrational numbers that are like decimals that go on forever. But I guess it's safe to say that they are definitely not fractions and they are definitely not decimals. So when we talk about these integer exponents, you don't want to be looking at fractions or radicals or anything like that. It's just a plain old negative number, positive number, or 0. And we have to talk about all the possibilities. The easier ones, of course, are the positive ones. The harder ones, of course, are the negative ones. And the easiest one of all is 0, which I have to show you. Now, I don't follow the book precisely. I think they do it out of order, personally. So I'm just going to give you all the rules and then let you be able to play with them. So rule number 1. Oh, well, before we get to the rule, let's talk about what it means to be an exponent and or power. Just to make sure you're on the same page as I am. This was also one of the little questions on the lab yesterday. What does it mean to be negative 2 times negative 2 times negative 2? Well, it's 3 factors of negative 2. And mathematically, to say that, you would write it as negative 2 is what's called the base. And then you would raise it to an exponent or power, which we would consider 3. And technically, the language there is, it's saying that there are 3 factors of negative 2. Which would be negative 2 times negative 2 times negative 2, negative 8, right? But here I just want to leave it as negative 2 to the third. So if you have a raised to the b power, the a is considered the base, the b is considered the exponent and or power. Depends on how you want to read it. But either one works perfectly fine, exponent or power. Now you got to be really careful of this exponent power setup. For instance, if I wrote negative 3 squared, what's it equal to?
9.
Positive 9, because it's negative 3 times negative 3, so that's 9. Because the base is negative 3, the exponent is 2. But then when I write this way, the answer is?
Negative 9.
Negative 9. Why?
Not in parentheses.
I know, but why? What property? There's got to be a reason why it's not the same answer as the one above it.
Oh,
In front of every number is what number? 1. So if I squeeze that in there, you get that. If I squeeze that 1 in there, which is the identity property of multiplication, you get negative 1 times 3 squared. Now, the base here is just plain old 3. It has nothing to do with the negative 1. The negative 1 is not being raised to the power. Just the 3 is. And of course the exponent is 2. So this becomes negative 1 times 3 squared. 3 squared is 9. Again, you have to do the square first because of the order of the operations. And then that negative just kind of attaches itself. So there's a big difference between negative 3 all squared and negative 3 squared. Now, older calculators, I don't see anybody that has an older calculator. If you typed in, it was backwards calculation. You would type in 3 first, and then you would type in the negative, and then you would hit square, and your answer would come out positive 9. But these modern calculators are order operation sensitive. So if you type in the negative first, the 3 second, and then you square it, your answer is going to come out negative 9. To get the positive 9, you have to put the parentheses. And there's a big difference between inside the parentheses and not inside the parentheses, outside the parentheses. So be really, really careful with that little setup. That will cause you a headache sometime during the semester where you're off by a sign and you can't figure it out. It's more than likely something like this. All right. See how those properties come into play to help you out? That's what they force you to do. They force you to find out why things work the way they work. And I'd rather you know how and why rather than just the how. Because how will get you so far, why will get you a lot farther in this class. All right, so let's go for the rules. Now that we've nailed down what an exponent is. Rules of exponents. By the way, these rules work for any type of exponent, not just integer, but we're just going to base them off of the integer values. So rule number 1, if you have a to the m times a to the n. Now let me read this in, it's written in mathematical jargon right now. Let me read it in English. Over here, when I wrote negative 2 to the third power, I read it as 3 factors of negative 2, because that's what it is. It's 3 factors of negative 2. So this would read
M factors of A.
m factors of a. This would read n factors of a. So you have m factors of a over here and n factors of a over there, and you're putting them together. So how many factors of a are you going to have? You have m of them, 5 of them over here. You have n of them, 4 of them over here. I put the 5 and the 4 together. How many do I have? 9. What operation did I do? Operation. You took the 5, you took the 4, and you did what with them? You added them. So the property here is you're going to end up with m plus n factors of a. n plus n factors of a. So base times base, you add the exponents. Base times base, you add the exponents. You need words instead of symbols. That's perfectly fine. All right, so for example, let me do it in a different color. For example, x to the 4th times x to the 7th is equal to x to the 11th, because it becomes 4 plus 7, and then you get x to the 11th. Notice nothing is happening to the x itself. You're just changing the exponent. So if I ask you to do, this is a weirder one, 3 to the a times 3 to the b, what would its answer be? Not changing the 3, it's just changing the exponent. So it becomes 3 to the a plus b. A lot of people, when they see that, they go 3 times 3 is 9, and then they add the exponents, which messes everything up, because that's not what you're doing up here with the x's. Why do it with the 3's? The laws have to apply for everything. All right, so that's rule number 1. Rule number 2. Let's see here. A to the m over a to the n. It would probably be easier to define this rule by an example, I think. So let's say I have a to the 5th over a to the 2nd. What does it mean to be a to the 5th? Come back to my language over here. The 3 here represents 3 factors of negative 2, which would be negative 2, negative 2, negative 2. So what does 5 factors of a look like? 5 factors of a. So a. What's a squared look like? A, Alcoholics Anonymous. And I can eliminate 2. Why?
Because it's like a over a.
Property? Nah. What's a divided by a? What is it again? Well, which one? It's definitely not additive, so there is no inverse. Multiplicative, that weird word. Or the multiplying inverse. So when you do a divided by a, what's it turn into? 1. It's really important that you put that 1 there, because sometimes they all disappear on the top and you're left with absolutely nothing. And a lot of people will put like 0 or something weird like that. A divided by a is equal to 1. It's the multiplicative inverse. You get another a divided by a is also equal to 1. Technically, there's a 1 in the bottom, too, if you want to write it. I mean, that's not going to hurt anything. So what's your answer?
3.
What?
A with a third.
Thank you. Well, 3a. That's addition, not multiplication. So this becomes a 3 factors of it. Where does 3a come from?
You subtracted by.
No, I meant in the sense of what does it mean to be 3a?
3 times a.
No. Well, what does it mean though?
3A.
3 a's that are added together. This would be a plus a plus a. So 3a is totally different than a cubed. What is it, dog?
Yeah.
Like, what the heck? What time is it? It's only 8:30. All right. So if you have 3a, it's a plus a plus a. If you have a cubed, it's a times a times a. So you try to keep those two straight. All right. So what happened to the 5 and the 2 to give you a 3? Subtraction. So the rule is, if you have a base divided by a base with exponents, you keep the base, and you take the exponents and you subtract them. Don't cancel the a's. I've seen people go, oh, a divided by a is 0. And then your answer, or a divided by a is 0. A divided by a is 1, and the answer, therefore, is always going to be 1, which doesn't make any sense. Okay. From this rule, there are some sub-rules. And these are the ones that confuse people. The sub-rules from number 2. When you're subtracting numbers, there's 2 answers that you have to worry about. One of them is easy, it's 0. The other one is a little harder, it's negative values. I mean, here I did 5 minus 2. Well, what if it was backwards? Then I would have 2 minus 5, and then I'd have a negative 3 as an exponent. And people hate negative exponents, they don't know what to do with them. So I need to show you what to do with them. Let's do it in the same power. A to the 5th divided by a to the 5th. Well, by rule number 2, this is a to the 5 minus 5, which is equal to a to the 0. Right? Base over base, you keep the base and you subtract the exponents. Well, the exponents are exactly the same, so the additive inverse comes into play and you get 0 out of the mess. But what does it mean to be a to the 0 power? Well, another mathematical way of doing this problem, using a property of mathematics, is what is a to the 5th divided by a to the 5th? It's 1. What property?
Multiplicative.
Multiplicative inverse. Identity doesn't change things. Inverses brings you to the identity. So this is equal to 1. Well, I followed a mathematical rule for the top one, and I got an answer. I followed a mathematical rule for the bottom one, and I got an answer. So the answers must be the same. So this implies that a to the 0 is the same thing as 1. A lot of times in math, you can prove things this way by doing something totally correct one way, totally correct another way. The results have to be equal. Otherwise, math would fall apart and the world would end. All right, the other bad thing would be this one. A squared divided by a to the 5th. It's just the reciprocal of the one I did over here to the left. So this would be a to the 2 minus 5, which is the same thing as a to the negative 3. All right. But I can also do it as a times a over a times a times a times a times a, and do it the long way. What happens? Well, a's will multiplicative inverse out. They'll cancel, which is what most people like saying. But a divided by a is 1. A divided by a is 1. What's your result? 1 over a squared. There's a 1 in the top. That's all that's left up there. And in the bottom, you have 1 over a squared. Oh, I was going to say there's 3 factors of a, so that would be 1 over a cubed. So these two answers must also be exactly the same. So if you're working with a negative exponent, the way I kind of think of it in my head, If you have a negative exponent, it's on the wrong side of the fraction. See, this negative 3 is on the top. It really belongs in the bottom. So here's my trick question of the day. What is 2 raised to the negative 3 power? What is 2 raised to the negative 3 power?
-8.
See, that's where people mess up. Do you see a negative sign anywhere here? A negative number. You see a negative exponent. Don't mix exponents and numbers. It never works. So notice what's happening. It's a to the negative 3 is the same thing as 1 over a cubed. So 2 to the negative 3 is the same thing as 1 over 2 cubed. The sign changes. It was negative there, it's positive there. What's 2 cubed equal to? 8. So this is the same thing as 1/8. When you're dealing with negative exponents, generally you're talking about a reciprocal. A reciprocal. So let me elaborate on those subrules real quickly. Over here, so I have some more room, and we can do an example. Subrules. So we're still dealing with the subrules. And they're pretty much, let's call subrule A, anything raised to the 0 power is going to be equal to 1. Anything raised to the 0 power, I don't care what it is, it's going to equal to 1. Subrule 2 is if you have a to the negative n, that's the same thing as 1 over a to the n. And then we can write its alternate form, which would be 1 over a to the negative n is the same thing as a raised to the positive n. If you have a negative exponent, it's on the wrong side of the fraction. If you have a negative exponent, it's on the wrong side of a fraction. All right. Let me steal an example out of the book. 0.4.
27.
You think 27
No.
is good?
No,
I
page
don't
27.
Understand that.
What's 27 look like? 27 is boring.
I said page.
I know, but 27 is boring. Let's do, what looks horrible? Ooh, this looks horrible. Number 36. I like going for the gusto. Negative 27, x to the 7th, y to the 10th, divided by negative 6, x to the negative 2, y to the negative 3. Why isn't that coming out? My battery must be dying. It's not writing right over there. Now, you've got to be a little cautious here. You know order of operations, right? Please excuse my dear Aunt Sally. It doesn't exist here. There is no order, per se, because the only operations here are multiplication and division. So the order is pretty much left to right. So don't think that there's an order to these rules. You don't have to do rule number 1 first and rule number 2 second and so forth and so on. You really just do what you can to make it as easy as possible. So what would make this easy? Well, mental-wise, what you do in your brain is you separate it into 3 separate problems. You can think of this as A times B times C type setup, where you have negative 27 divided by negative 6 times x to the 7th divided by x to the negative 2 times y to the 10th divided by y to the negative 3. Why is that possible? Well, because it is multiplication and division all the way across. How do you multiply fractions together? Straight across. So you get negative 27, x to the 7th, y to the 10th. That's exactly what's in the top. How do you get the bottom? Well, negative 6 times x to the negative 2 times y to the negative 3. That's what's in the bottom. So you can separate it as individual fractions. Number to number, x's to x's, y's to y's. Now, instead of solving one huge, ugly problem, you can solve one little problem at a time. So you can start with the numbers and be really, really careful. numbers do not follow the rules of exponents. Because these two numbers are negative doesn't mean they're on the wrong side of the fraction. That only works if it's negative exponents, like these two here. So when you do negative 27 divided by negative 6, what's it equal to?
9 over 2.
What is it?
9 over 2.
Negative divided by negative is a positive. So you're going to get 9 over 2. And I'm going to leave him by himself for now. Eventually I'll put them all back together. Now here you have two options. You have base over base. What can I do with the exponents? Subtracting. There is a second option if you want to use it. You can use this rule here, part B, the second part of it, and you can take the negative exponent and bring it to the top. I can take that x and negative 2 and put it up here as x squared. But either way will work perfectly fine. Most people like to do the subtraction first.
I don't understand that.
Which part?
The 1 over a negative, exponent.
Oh, this part?
Yeah. And you said you just bring it to the top.
Yeah, the top of a fraction.
So they cancel out.
No. You're forcing this, instead of to write it in the bottom, you're moving it through the fraction bar and you're writing it on the top. And notice this one's negative and this one is positive. They're equal. They're the same number. Same thing with here. If you have a negative exponent in the top, if you force it to go into the bottom, it's kind of like just moving it down, then the exponent becomes opposite sign. But if it's negative here, it's positive there.
So if it's positive on the bottom and you move it to the top,
It becomes negative.
Okay.
Yeah. So if you move through a fraction bar, the exponent is going to change sign.
So in this example, like you move it, if you move x negative 2 to the top, it would be x to 7 plus x.
X
how would you
to
move
the
it?
7th times x to the 2nd. But eventually you're going to add the exponents. Okay. So which one do you want me to do? Move it up or just operate it the way it is? Do it the way it is? All right, so if you have a base over base, what do you do with the exponents? Subtract them. And I'm going to write that in step by step. So you're going to get 7 minus, be really careful, negative 2. It'll be x raised to the 7th minus a negative 2. And that's probably one place where a lot of people have trouble, and they'll be better off just taking that and forcing it to the top. But either way, it works out the same.
So then you just want to add it.
Yeah, because negative is a positive, and it would be 7 plus 2 is 9. Here I'm going to do it a little different. I'm going to write it as y to the 10th, and I'm going to drag him to the top so it becomes y to the 3rd. So I can show you both styles and that they actually do turn out to be exactly the same. All right, so you still have this 9 halves. You're going to get x to the 7 minus 2, which is, that's horrible language. It's actually minus a negative 2. And that becomes 7 plus 2, which is x to the 9th power. And then here you got y to the 10th times y to the 3rd. What do you do with the powers there? Add them. And you get y to the 13th. Now, if you did the subtraction on that second one, it would be 10 minus a negative 3, which turns into 10 plus 3. So you get the same answer, which is kind of cool.
So that x to the 9th and y to the 13th is not in the numerator or the denominator?
It's in the numerator. Because remember, you can always put this over 1. Now, there's two ways of writing this answer. You can write it as 9 halves times x to the 9th times y to the 13th. Or you can write it as 9x to the 9th, y to the 13th, all over 2. Those are exactly the same answer. Those are exactly the same answer. So I don't care which way you write it, but pick one. Now, you would get this answer if you didn't separate it the way I did. You would get the bottom one. If you separate it the way I did, you're going to get this answer, where the 9 halves is kind of sitting out front, and then you have your answer afterwards. Some of these you're going to have variables in the top and the bottom, so you got to be kind of cautious. Let me do another one. The answer to that should be oh. And then you get your homework and you fall apart, and then I have to put the pieces back together. One more. What's a good one? How about this? You do number 34. I'll write it on the board in case you don't see the book. Page 34. Do number 34 on page 34. It's an easier one. 40 over minus Nice simple one. Negative 8b. Everybody okay with that?
Yes.
No no's? You sure? Just real quick, just in case, I would write it this way to begin, just to keep it organized. How would you write the b in this fashion?
B over
b over 1, just to keep it as a fraction. Just in case you're left with a fraction at the end. 40 divided by negative 5. Negative 8. A cubed divided by a cubed.
A to the 0.
Which is also the same as 1. If you leave a to the 0 on a test, I take off a point. Because a to the 0 can be reduced to 1. Square root of 4 can be reduced to 2. 6/8 can be reduced to 3/4. It took a while there. Anytime you can write a simpler expression simpler, that's what I'm going to be looking for. So this should be 1. And then b over 1, of course, is just b. And then negative 8 times 1 times b is negative 8b. Good. All right, homework. Do all the checkpoints in 1-4. There's a few rules that I haven't gotten to. Power to a power, reciprocal properties. So I'm just going to assign homework on those. But try to do all the checkpoints in the book. They do checkpoints, don't they? Practice problems is what they call them. Practice problems. They're right after every single example. There are 17 of them. I don't expect you to get through all 17. At least get through 9, up to number 9. So do all those practice problems up to number 9.
What page?
They start on the beginning of 1-4, which is 26. They're right after every single example, little orange boxes. You'll see them. So do the practice problems up to number 9. And then on page 34, I'll write it down. The PPs, 1 through 9. And then page 34, the only ones you can do are 1 through 35 odd.
Why not even?
You want to do evens?
No, I thought I was gonna be.
No, the answers, well, I think the answers are out on the back of the book. Yeah, the odd ones.
I thought you.
So, my suggestion is do like 3 of them in a row before you look at the answers. And then go back, and if you don't get the right answers, find out what you're doing wrong. Make sure you're following the rule properly, a property properly, and so forth and so on. Tomorrow is the lab. The lab will be based on this junk and properties, again. Homework is due on test day. But I highly suggest you get it done before the lab, and quizzes, and all that fun stuff. Other than that, I'll see you tomorrow upstairs. In other words, go back.
Hold on. Stop recording.